All right, so we're going to talk about different types of symmetry first. So you can have a y-axis symmetry right here. So that's when you flip it. This is an x-axis symmetry. So if I flip this here, you get the picture back. You can also have a symmetry about the origin. So that's when you do a double reflection. That's symmetry about the origin. Some people also call it the 180-degree rotation. So this is more of a origin rotation. So that's this down here. So if you're looking for points in how we do it, so if you have an x-axis symmetry, that means that all the y values have changed from positive to negative. So that's why you see that this has changed here. Also, if you plug in y and negative y, then you should get equivalent equations. That means that if I plugged in an equation, I'll show you the bottom, y or negative y, you get the same. So a y-axis is like right here, the absolute value graph. If I plug it in the x and a negative x, I get the exact same answer out. So that's what this one right here is saying. For an origin, it's a double reflection. So your x's both and your y's both change. So if we look at some pictures down here, so right here, if I reflect this over, like it's the exact same picture of the y-axis, so that is why it would be a y-axis symmetry, right? And then this right here, if I looked at this point and I changed both the signs on them, I get this one down here. Or if you think about flipping it over the x and the y-axis, so do a double flip, then you get the picture back. And then this one right here is an example of our x-axis. So if I took the top picture and I flipped it down, I get the bottom picture. And they have some points here that we've checked. And so that's why it would be x-axis. You could also, if you looked at it this way and we flipped it here, you could also get the picture back on that image. And so that would be a y-axis symmetry. And so we're doing right here to show you how you would figure out the symmetry. So right here, if I plug in x and negative x, I do not get the same equation out. So here's your equation. And then if I plugged in negative x, it'd be the cube root of a negative x and then a minus 1. That's what it's down here. Those aren't the same thing, so it can't be an even. And then this is what it would look like to plug in a negative y and a positive y. Those aren't the same thing, so that's why it's neither. And this is what it would look like if it was an even function, which is a y-axis symmetry. So if I have x and I plug in a negative x, the absolute value of negative x is still x. So then I'd end up with the exact same equation here. If we check our y's, it doesn't work. So down here, this is an x-axis symmetry. Do you see how if we put a negative y in there, it came out the same answer? So that's how you could do it. You could also, if you wanted to just check for them too, I should have said this over here. Let me go back. So if you plugged in like a 2 for an x and a negative 2 for an x, you should get the same answer. Down here, or this one, if you plugged in 2 and negative 2 for your y's. So you plug this in your y's, you should get the same answer. You plug these in for your x's, you should get the same answer. So down here is what I was just saying a second ago, your even and odd functions. So a function is even if it's symmetric about the y-axis, and it's odd if it's symmetric about the origin. So that's the double reflection. So this means if I plugged in 2 and negative 2, I'm going to get the same answer out. And this one here, if I plugged in 2 and negative 2, I should get the exact opposite answers out. So that's how you should learn in Algebra 2. And we're trying to do a little bit more here. So right here, if I plugged in 2 and negative 2, my answers are going to be, it's the 8 minus 2, so I'm going to get 6. Negative 8 plus 2, so I get negative 6. Since these answers are opposite of each other, they're odd. Now, the pre-calc way to show that is here's the function, if I plug in negative for my x's. Do you see these two right here? If I pulled out a negative sign, I get negative x cubed minus x. Since these are the same functions, when I pulled out a negative, that's what makes it odd. So down here, I have negative x squared. If I plug in a negative x squared is just x squared. This is the exact same function here, so that's why it's even. If you check 2 and negative 2, you should get out, see, 4, negative 4. So you should get out 2 each time. So since it's the same number, that would be another reason it's even. This one down here, if you see, if we plug in a negative x here for each one, then I get, let's see, plug in negative x. So right here, it's not actually changing signs. So if I pull in a negative here, I don't get the exact same thing back that I had originally. That's why it cannot be odd. And then if you plug it in, the negatives, you won't get the same function out. So down here, if I plug in a negative, it's square, so it stays positive. So this is the same function as that one. That's why this function right here would be called an even function. Again, you can practice trying with 2 and -2 and see, do you get the same number or are you getting opposite numbers out? So down here, when I plug in a -x, I have a -8 over -x. That becomes 8 over x. So these are not the same, so it can't be even. But they are opposites of each other. If I pull out a negative, I get the same function. So that's why it's called odd. So down here, and I plug in a -x, it's not the same function. If I pull out a negative, I can't get the same function either. So that's why that one right there would be an even function. I mean, a neither function, sorry.